Hey guys, BuildZoid here, and today we're going to be doing a nice low-effort video where I just go through all the different 6700 XT PCBs that are listed on Tech PowerUp, because I've been seeing requests for... at least one person has been asking about PCB, like some kind of PCB roundup or breakdowns of 6700 XTs, so I figured we may as well do these. Since, yeah, the thing is, I don't find, like, for the same reason that I haven't done PCB breakdowns for, like, 6800s and 6800 XTs and regular 6900 XTs, I don't find 6700 XTs very interesting, because it's not super overclockable, you know, yeah, though I think the 6700 XT does, I believe the 6700 XT is currently on a 3 gigahertz core clock limit, which is still too low in my opinion. Especially like these should be easier to cool than 6900 XTs. So if you added an EVC to these, you might actually max it out even on like the air cooler. Yeah. Anyway, let's just get right into it. Starting off with the Asrock 6700 XT. Actually, we should start with the reference card, right? Because that's sort of usually that's the bare minimum. Though with AMD, it's an interesting situation where a lot of the time the reference design from AMD is actually pretty good, and then the different various board partners are trying to figure out ways to make it cheaper. So what do we have here? We got this. So we're actually going to go to the back of the card, because here we can sort of see the layout of the power delivery. So we have a single-phase memory VRM over here, single-phase VDDCI. You can see the splits in the power plane right there. And we've got a split in the power plane over here as well as over there. So I'm guessing one of these is SoC voltage and the other one is core voltage. And then on this side, we've got this nice long continuous block, right? Like this is all one piece. I hate the middle mouse button. Do I? Wait. Oh no, I have it. Oh, cool. Okay, so I was like, wait, did I not rebind that? I did. Anyway, so yeah, we have this nice continuous power plane right here. So this is all V-core again. So we're looking at, what, 2 phases V-core over there. What's kind of neat is you can actually count the phase count from just how the power plane stitching is done. Just, yeah, so we've got 2 phases over here for V-core, then we've got 5 phases over here, so 7-phase V-core, 2-phase SoC power, 1-phase VDDCI, so that's memory controller, and then 1-phase memory power. The voltage controller is an IR35217... Is that the only controller we have here? So that doesn't do enough phases for this. And there's an NCP81022. Well, this will be in charge of the memory and the... Yeah, this will be in charge of the memory and the... What's it called? Memory controller. Yeah. Whoa, that took forever. So yeah, that'll be in charge of the memory and the memory controller. And then the V-core. So I'm not sure what they're doing on with the SoC rail, because that actually might be a single phase then. I'm not seeing a doubler. Like, because you can't run 9 phases off of the IR35217. This is an 8-phase controller. It only goes up to a... Like, you can do a 6+2. You can't do a 7+2. Though, I guess what they could do is actually have the IR35217 in 7+1, where it handles VDDCI, and then the NCP81022 would be handling the SoC rail, and then it all works out, and you don't need any doublers, you don't need to put power stages in parallel, you don't need to do anything super weird. Also, notice how the input filtering on like a freaking 6700 XT has way more capacitance than a 6900 XT. Like, I have no idea what happened with the like high-end 6000 series cards, because here we've got an input filtering capacitor literally for every single phase, and on a 6900 XT you've got like a grand total of 6 of them for the entire card. Right, so here we've got like we've got that many on like this side of the card alone. Anyway, output filtering, we're just looking at a mix of through-hole capacitors and multi-layer ceramics, because that's far more that's generally a more cost-effective way of doing your output filtering than using SMD polymers, because SMD polymers are very, very, very expensive compared to their through-hole counterparts. Yeah, I mean. It's a they've done some cost optimizations on the multi-layer ceramics for input filtering over there, but Yeah, like that's not going to affect stock operation. So yeah, so that's the VRM configuration, I guess. Right, I'm still not sure how the phase assignments are done because you can't run a 7+2 off of the 35217. So I'm assuming it's 2+1 on the 81022 and then 7+1 on the 35217 because that would actually like work. Anyway, what else do we have? We've got SIC 632As, which we're just going to look up. Yay. And these are 50 amp integrated power stages. These are pretty dumb, right? Yeah, we've just got a thermal warning system, so no built-in current sensing or anything like that. So these are just sort of, like, these are basically DR-MOS components. The thing is, you can, like, DR-MOS components don't even, like, require the like, thermal warning output that this has. Anyway, yeah, so that's the reference design. And so we've got what, like 7 times 50 amp power stages for V-Core. How much power do these pull? Because that's kind of the thing is like you always have to consider the VRM relative to the power, like how much power you can actually push through the card. And oh, that's 20 millisecond spikes. Well, that's like that doesn't really affect the VRM very much. Right, like that. This is actually kind of useful. This like 20 millisecond spikes is kind of where that 50 amp like sustained current rating is sort of useful. Because if you scroll through something like this, yeah. So here we have the like different efficiency curves, and it's like so. Like you do not want to be running this power stage at 50 amps output. Like you just don't want to be doing that, right? Like you're going to be hitting like 76% efficiency at, that's admittedly on 1 megahertz switching frequency, but yeah, you can see how that is a very bad idea. And if you actually look at the power loss, you know, at 45 amps output, this thing will be producing like at a minimum almost 8 watts of heat, which is going to be very hot. So you can do like 50 amp spikes because, you know, it won't be averaging a heat output of 8 watts, but you can, so that's sort of where like the nominal current rating is sort of more useful, is for like sudden burst power loads, and then average power draw you actually want to be well away from the maximum current rating of the power stage. Funnily enough, most power stages actually have like a even higher current rating for like short-term burst loads. Which I'm not sure, like, it depends on the manufacturer. Like, there's some 50 amp parts that have, like, a peak current handling capacity, like a 10 millisecond peak of, like, 100 amps. But it looks like Vishay doesn't include that in their specifications, so, yeah. But you don't really want to be running 50, like, this is not, basically what I'm trying to get at is this is not a 350 amp VRM, because it would run way too damn hot at that point. But yeah, for like a 200 watt card, this is totally fine, right? And then even with overclocking, you're probably not going to make it pull that much more power. Yeah. So I see, like, so that's the reference design. Let's see if there's anything better. So let's go to. We're gonna keep the reference design up, just as that. Oh, I guess we could do the Asrock card, which is the same thing. Yeah, this is literally the same thing. We've got two, you know, we've got like SoC or V-Core, then we've got two more. Actually, if we go to the back of the card, it'll be more visible. Yeah, so you've got your memory, VDDCI, whatever this is, whatever that is. One of them is V-Core, one of them is SoC. I just without the card in hand, it's impossible to tell. And then the rest of this is V-Core, so we've got another 7+2+1+1 configuration. I'm assuming the exact same power stages or very similar power stages. SiC, yeah, so we're just going to look those up instead. That's the wrong part. Oh, wait a minute. Is this the ones that are, like, impossible to find? Asrock, why you do this? 649. Oh, no. Yeah, I'm pretty sure these are the ones that I've just not managed to find. So let's go to Vishay's website. 9? Yeah, no, so this one's not public, which is annoying, but that's probably another 50 amp part. Actually, if we go to like a 645 or something, and then actually it might be a 60 amp part. Oh, come on, I was hoping it would get us to like the power stages. Where is it? Power modules. They've changed their website. Oh, there it is. VR powered DR MOS. Yeah. So here we have, and so we have the 645, which is a 60 amp part. There's a 642, which is 50, 647, which is 50. So, yeah, like I have no idea what that's rated for. It's probably a 50. Yeah, that's just impossible to tell because like I was hoping that there'd be like a clear pattern where it's like bigger number is better, but it really doesn't work. So yeah, like because we have like a 647 that's a 50 amp part. We have a 642 that's also a 50 amp part, and then we have a 645 which is a 60 amp part. So it's like, well, I have no idea what a 649 is supposed to be then. But it's not going to be rated below 50 amps because that would be going below the reference specification. And like Asrock has basically taken the reference PCB here. They've added some RGB stuff. They've added a BIOS switch, which is a nice little addition. Not that there's not really any BIOS modding you can do on AMD GPUs these days, though. So that doesn't really help you in any way, shape, or form. Actually, are we even using similar... Well, output filtering on the reference design was APAC. The input filtering capacitors look kind of Nippon Chemicon, but I'm not 100% certain on that. This is all APAC capacitors, so very popular brand for like sort of budget products. Like your high-end stuff will usually use like Nichicons or Nippon Chemicon capacitors. APAC is a Taiwanese manufacturer. They generally make good capacitors. Like the thing is, these are through-hole polymers. They just kind of they're solid, right? So they don't have the whole liquid like the issues that liquid electrolyte capacitors would have. Like this just doesn't apply to these. They're a completely different construction. So yeah, I don't have any problem with that. Yeah. We've got basically, so this is basically a reference card. Let's see what Gigabyte did. I'm pretty sure, so actually Gigabyte is interesting because they tend to go, they tend to not be complete, like, well, this is still a reference VRM configuration, right? We've still got the, if we go to the back, because it is really most visible on the back. So we're going to close down the Asrock one because that's just a reference design. So harder to see here, but yeah, you've got that split over there. So we've got our two phases, then we've got another split, then we've got VDDCI. You can just about make it out. At least I can just about make it out. I don't know how it's going to encode onto YouTube. Then we've got our single phase memory power, and then on the other side we've got 5 phases of V-core, don't we? Yeah, 5 phases of V-core. So another 7 plus 2 plus 2 plus, 7 plus 2 plus 1 plus 1. Gigabyte has swapped out all the inductors for what looks like a much lower inductance, right? Yeah, this is the reference AMD design with like 33 nanohenry inductors and 56 nanohenry input filters. And then Gigabyte over here is 150 nanohenry input filtering inductors, which those aren't for filtering switching noise from your power supply. Like they'll kind of do that, but they're not really there to filter like incoming power. The idea behind these is to prevent the switching noise from the GPU from like affecting everything else on the 12-volt rail. So that's what those are for. They're basically to keep the GPU noise in the GPU and to keep the other noise out of the GPU. So I guess they kind of do filter incoming power, but it's like that's the primary, like there's a lot of GPUs, like actually there's not that many GPUs, but there are certainly GPUs out there that just don't bother with having input filtering inductors because and generally you'll see that on lower power cards because they're not going to have huge power transients, so you don't have to worry about that too much. So interesting that they've opted for lower inductance inductors. And then, same input filtering configuration in terms of capacitors. Output filtering capacitors output filtering inductors are also lower lower inductance, which could actually lead to ever so slightly better transient response, especially in overshoot, because your overshoot, like the source of overshoot on a load release is the energy stored in the inductors. If you use lower inductance inductors, they don't store as much energy. So you get slightly better, like depending on the VRM design, you can get slightly better voltage regulation performance. The downside to this is they do reduce your power stage efficiency because the RMS current through each phase goes up. So this will be a slightly less efficient VRM, but with maybe slightly better transient response. And we're looking at more SIC 649s, which, as we've discovered, don't have a public data sheet. Then we have an NCP 81022 and an IR 35217 for the voltage controllers. So yeah, typical reference design. This is like Gigabyte's take on a reference design. They've added some LEDs to indicate the power connectors being plugged in. I'm kind of wondering where the I2C header is. Oh, it's up there. Yeah. So there's your I2C header. I'm assuming it's in the same place. Yeah, it's up here for the reference card. They even labeled it. Yeah, so if you want to hook up an Elmore Labs EVC2 to this and bounce off the 3 gigahertz core clock limit on air cooling, that's how you're gonna, like, that's where you can hook up for voltage control. And yeah, it looks like everybody's going to be keeping that same positioning, because like, why would you change that? Well, Asus actually, I think Asus has a pretty unique 6700 XT PCB. So speaking of Asus, let's take a look at what they've done. So yeah, Gigabyte, basically the same as reference, with potentially slightly better transient response. I don't really think you're gonna, like, I don't think it will be like even not a noticeable difference. It's just kind of like, yeah, it's different, and on paper it should lead to better transient response. In practice, it might be like the thing is, overshoot is like not a concern under most circumstances. Unless it's really, really bad, you don't have to worry about it. It's just kind of like, oh yeah, it looks ugly on the oscilloscope. Undershoot, on the other hand, is more about how the other parts of the VRM design. And so yeah, the changes that Gigabyte has made won't really significantly affect the overclocking capabilities of the card. Anyway, let's take a look at what Asus has done, and yeah, so this is very different, right? This is the first card that doesn't look completely reference. And let's also get the back. So I do like what they've done with the capacitor configuration here, right? Asus has added a bunch of what look like Panasonic XP caps to, well, all of the power rails, just all of them. Like, we've got one for memory, we've got one for the VDDCI over there. So I guess this middle part is VCore because that's got the most phases. Then we've got the SoC down there, and then we've got more VCore over on this side. So we've different phase arrangement, right? We've got, I think, still 7 phases for VCore, I think. How many do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so still 7-phase VCore, 2-phase SoC, 1-phase VDDCI, 1-phase memory. I'm assuming we're still looking at the same voltage controllers. Yep, NCP 81022, IR 35217 for the main power rail, for VCore at least. And I do like the addition of the SP caps. This is actually probably gonna, the SP caps are more significant than what Gigabyte did to their inductors. On the flip side, Asus has seemingly decided that they're gonna use the 6900 XT approach to input filtering, because where did all the input filtering capacitors go? Right, we've got these 270s over here. So where's the reference design? Here's the reference design, right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've literally got a capacitor for every single phase. Here we have, well, if we go to the front, we've got these over here. These are 56 microfarads each. So each of these is actually a small fraction of what you have in one of those through-hole capacitors on the reference design. Now, admittedly, these tend to have, will have less ESR and less well, actually not necessarily ESR. They will have less ESL, so they can be more effective, even though their capacitance is much lower. However, that still doesn't change the fact that we've gone down to a grand total of 7 capacitors from 11. I'm not a fan of that. Yeah, not a big fan of what Asus has done here. Like, I don't even, like, I don't get why they've done it. Because, like, they have a real, like, they've upgraded the output filtering, and then they just sort of threw out most of the bulk capacitance on the input. I guess they came to the conclusion that most of it wasn't necessary, but, like, isn't this one of the most expensive 6700 XTs you can buy? Where did my capacitors go? So, yeah, anyway, in terms of the power stages, I'm assuming we're looking at about... Oh, man, it's all 649s. Oh, no, these are 643s. Yeah, these are 643s. Yeah, that's a 643. Are these public? Probably not. Let's try. SIC 643. No. Of course not. So I'm guessing they're also either like 50 or 60 amps. Yeah, like so far we haven't seen anybody change like we've not seen a significantly different power stage. Anyway, let's take a look at what MSI has done. So basically, Asus, I like what they've done to the output filtering. I am not a fan of what they've done to the input filtering. I don't think it really, with a 6700 XT, that's actually like here it shouldn't make as much of a difference as. Wait a minute, I missed a few caps, because oh yeah, they've got these on the back and also that one over there. So it's not as bad as I initially thought, right? Like that does bring up the total to what, like that's 2, 3, 10. Yeah, that brings up the total of input filtering capacitors up to 10, so that's not too bad. Like, it's not as bad as I initially thought. Going from 11 to 7 is, like, that's a pretty significant downgrade. But, yeah, so I like what they did to the output filtering, but other than that, it's just sort of more of the same as all the others we've seen so far. With a very different input filter, which might actually work better. Like the SMD polymers for the input filtering might actually be like an upgrade over the through-hole capacitors. It's just without the card in hand to test, that's impossible to say with certainty if that's the case. So let's take a look at what MSI has done. And man, I love these inductors. I absolutely love these freaking inductors. Like, who doesn't want dragons on their inductors? So yeah, like if I was buying a 6700 XT, I would get this one just for the inductors. Not that it makes any significant difference. It's just it's just neat, you know? Like I miss having like silly looking hardware. Like everything's just black, like monochrome these days, and I find it very boring to look at as a result of that. And so, you know, having red dragons on the inductors is like, functionally doesn't make a difference, but I think it looks neat. And it looks like MSI's actually got more phases than everybody else, because we've got 6 phases on this side, and then we've got, you know, 6 on this side as well. Okay, how does that work? Let's take a look at the back of the card. So this side is all V-core. Yeah, so this entire side is V-core. Got a 1-phase VDDCI, 1-phase memory. So I guess they're... Wait a minute, I can see it. Those are 3599s. Yes, those are going to be 3599s, which means I just didn't spot the other ones. Where are the other 3599s? Also, why does Google, like, blur the image when it's not zoomed in? Like, this is... By that I mean Google Chrome. Like, why does it do that? Yeah, so we have a 3599 here, a 3599 there, another one over here. Okay, so that would explain how we have 6 phases on that side. That looks like a 3599. It certainly has, like, traces going over to... Yeah, so that's a 3599. How many of them do we need? Oh, so this is going to be a 4-phase to 8-phase for V-core. Yeah, okay, that's what's going on. Yeah. Because you've got 2, 6, yeah, 8. So you only need 4 of them. Okay, I was searching way too hard. So, yeah, so this is the first card, the first and only card to use doublers. those can lead to, depending on the rest of the VRM design, like they can lead to slightly worse transient response because they delay the PWM signals from getting to the actual power stages. However, like from like testing VRM designs with and without doublers, depending on how the rest of the VRM is designed, it doesn't make a difference. So I really wouldn't like I don't see them as a downside. It's just interesting that MSI has opted to use them. Also, what's nice from MSI is they actually have input protection fuses on every single one of their inputs, which nobody else is bothering with. So if for any reason like a power stage or something fails, these will hopefully blow fast enough to prevent any further damage. So that's a nice touch that we've got those fuses. Though, you know, at the same time, so the fuses are a nice touch. It makes the card slightly more repairable in the event of a power stage failure. Or at least it makes it more likely that the card might survive a power stage failure. Because a lot of the time, like, if you don't have any kind of protection, a power stage failing can just destroy everything on the output of the VRM. Or just burn a really big hole through the PCB, which is also, you know, annoying to deal with. So yeah, the fuses are nice. I like the inductors. Capacitors are the same we've seen as before. Well, these are a different manufacturer, but they're still 5,000 hours at 105 degrees through whole aluminum polymers. And for the power stages, we do have different power stages. This is on NCP 302155s. So the nice thing about these NCP parts is that you can actually tell just from the part number if this is a 55 amp power stage, and it is. And you might be like, what's the difference between a 55 amp part and a 50 amp part? Not much. So yeah, anyway, up to 2 megahertz switching frequency. Not that you would ever want to do that because, like, you saw some of the earlier charts, like, cranking the switching frequency just tanks the efficiency. Yeah, you can see it again here. That's at 19 volts. We need 12 volts. Yes. Okay, so here we've got some 12 volt performance curves up to 92% peak efficiency. The thing is, there's differences in how each manufacturer measures their performance, so not super comparable. Like, you can't take the documentation from On Semiconductor and compare it directly to Vishay, expecting to get like you'll find some weird weird disparities in the efficiencies if you try to do that. But yeah, the heat output looks fine all the way up to 40 amps. I mean, like, at 40 amps, obviously, it's basically unusable due to how much heat they're producing, but, you know, at 20 amps and at, like, the useful current range, we have a pretty normal power efficiency for, like, a 50 to 60 amp power stage, so nothing to really be surprised by. So this technically, like, so the MSI card technically has a more powerful VRM than everything else we've looked at, mostly because it just has more power stages, right? Because this is an 8-phase V-core with doublers, whereas all the other ones were 7-phase. So yeah, so this is neat. Yeah, so that's the MSI card. Or really, like, this is the reason I've not been doing 6700 XT PCB breakdowns. Like, not only is the overclocking limited, most of them are just reference cards. Hey, look, another one. Nichicon FP series capacitors on this one, so that's interesting. I think, well, I don't know what MSI is using on this. I don't recognize the markings on these capacitors, but the Nichicon is a Japanese capacitor manufacturer. So these are FP caps from Nichicon. This looks exactly like reference, though Sapphire has added input protection fuses, so, or more like board protection fuses. That's the better term, yeah. So board protection fuses onto the card. Same VRM configuration as the reference design, yep. So we're looking at another 7 plus 2 plus 1 plus 1. There's not really, yeah, they've basically just switched over from, like, Taiwanese manufactured capacitors to Japanese manufactured capacitors. I really don't think that's a that might sound like a significant difference, but nah. it really shouldn't, like, it really shouldn't be. Not like, I don't know, maybe several years down the line, the voltage regulation on this card will be holding up a little bit better than on some of the other ones if the card's been running at really high temperatures for very long. But other than that, it really shouldn't make a difference. Because the thing with polymers is as they age, they just get like their ESR increases, their ESL increases. So they just become less and less effective at doing their job as a capacitor. But the stock design normally already, like the reference designs will come with more than the minimum amount of capacitance necessary to begin with. So even after several years of, capacitor aging, it's not really going to, like, it won't affect the operation of the card very much at all. If at all. Like, like, at stock, it should, like, it won't, it shouldn't make a difference whatsoever. Anyway. Yeah, so that's the Sapphire card. I will say, like, if of the cards that just take the reference PCB and don't really do much of anything with it, I do like what Sapphire has done. Like adding the fuses, mostly the fuses. Like the capacitor swap is just kind of like, whatever. But the fuses are really like, those are a nice addition. And then we've got more 649s, so we won't know who made so yeah. So probably 50 amp parts again. And then we've got the Merc 319 from XFX, which this is literally a reference card. Yeah, this is... Oh no, they've added a BIOS switch, right? Yeah, this is the AMD reference. This is the XFX. They've added a BIOS switch. They've lowered the input filtering inductance again. The reference design has 56 ohms for some reason. Also, I need to figure out why Google Chrome just blurs photos when they're zoomed out. This is really starting to annoy me. Anyway, yeah, so they added a BIOS switch, which, did Sapphire do that? Oh yeah, they've added it on the other end of the card. Or at least, that is a BIOS switch, right? That's not like a LED switch. I can't read that. Well, I have no idea what that is, but they've added some kind of switch, and then XFX has also added a switch. 7 plus 2 plus... Yeah, this is literally a reference card with just different inductors, different, like, different manufacturer for the capacitors, because you're, like, each manufacturer... Well, most manufacturers... Well... Like... There's a lot of companies that make capacitors, and so, different companies source capacitors from different capacitor manufacturers. So, yeah, there's not really anything weird about that. Yeah, I don't see anything noteworthy to talk about on this card. This is just like, it's very reference. Looks like they've added some extra SP caps to the memory, though. Yeah, they've added some extra capacitors to the memory filtering, of all things. Right? Like, we've got those. Yeah, those are on memory. So they've added some extra filtering to the memory. That might lead to slightly better memory overclocking. And, like, do these even allow you to set the memory clock that high? That's always the question with modern AMD GPUs, is like, are you allowed to overclock this? The answer to that is no. It's like, no, like, why would we give you a proper memory slider when we can just limit it to 2150? Yeah. So those capacitors that XFX added, just completely pointless, because you can't actually overclock the memory on these cards. Thank you, AMD. Very cool. And then we've got PowerColor, and whoa, okay, we got a lot of phases, right? And doublers. Yup, lots of doublers. I've seen two of them already there. 10 phase? Yeah, 10 phase. And then we've got more doublers hiding in between the capacitors on this side. So we've got a 10-phase V-core, so going 5 phases through doublers to 10 phases. 2-phase SoC rail, 1-phase... Wait, did they bump up the memory? No, they didn't. Yeah, VDDCI is still the same size. Memory is still the same size. Looks like PowerColor at some point thought that AMD would allow these cards to be, allow more memory overclocking on these cards, but, because 'Cause look, we've got extra capacitor options. Wait a minute. Did they just ditch all the multi-layer ceramics? Oh no, they've moved the multi-layer ceramics that you normally see on the back to the front. And then they were like, yeah, and then we're going to add some nice SP caps. And then AMD was like, no, you won't, because we won't let people like, why would we let people give people a reasonably sized memory clock slider? No, we don't need, like, yeah, no, no more memory clock sliders. So, yeah, so PowerColor has done like, I really like this. This is a really nice PCB. Low input filtering inductance. Lower inductance inductors just across the board for the whole VRM. But with the higher, well, yeah, so lower inductance inductors across the whole VRM. APAC capacitors, you can tell from the logo on these. And then we've got NCP 302155, so 55 amp power stages again. So, yeah, like this is actually the nicest 6700 XT PCB. Oh, and then we've got, looks like a BIOS switch. Do we have, actually, we could just look if we have two BIOS chips. Yeah, we have two BIOS chips. So this is dual BIOS. Actually, I could have checked that on the XFX card as well, and the Sapphire card now that I think of it. It's just like, how many BIOS chips? Two. Okay. Is this the Sapphire card? No, this is the PowerColor card. This is the Sapphire card. Yeah, this got two BIOS chips as well. Interesting that, like, wait a minute. What? No. Why does it... Is that not a BIOS chip? Am I... Because, like, you have the pads for the second BIOS chip right there, and then what's this over here? Nobody else has that. I'm going to assume it's another BIOS chip, because there's not, like, even on the front of the card, there's nothing here. It's not like they moved something to the back, so I guess they just put a weird location for their second BIOS chip. Anyway, but this has dual BIOS, has the most phases, has roughly the same, power, roughly the same current capacity power stages as every other card. Yeah, good job, PowerColor. Best 6700 XT PCB. Not that it's going to really do anything for you because you can't overclock these. I mean, to be fair, like on air cooling, well, no, yeah, that like it isn't going to do anything for you because like the voltage slider doesn't go very high. So, and you're not going to take these on LN2 because as far as I know, these have a 3 gigahertz core clock limit. So it's just like, that's a total waste of time. And like, because somebody's going to be like, but why would you put a 6700 XT on LN2? That sounds completely stupid. Let me show you something, okay? Oh boy, why is there so many GTX 1060s? NVIDIA, why? Yeah, so see this right here? That's a GTX 1060 on LN2. Won't be doing that with a 6700 XT because you can't overclock them. So yeah, thanks for that, AMD. Literally worse than NVIDIA at this point. And there's actually quite a bit of competition for 6700 XT overclocking, like, already. Because it's, like, this is probably, like, under most circumstances, a 6700 XT would be a really, really popular GPU for people to buy. So, yeah, like, there's already, like, a decent amount of competition in the TimeSpy rankings. Like, this person over here is basically at the clock limit on air cooling. Like, AMD, are you kidding me? Reported clock speed, yeah, peak clock of 2840, average clock of 2735. So yeah, if you gave one of these cards a little bit more voltage, you would probably max out the slider in the AMD drivers, and that would be the end of what you can do. So yeah, that's the 6700 XT PCBs. The vast majority of the cards they take the reference PCB, they don't really change anything. and they ship it. Or, well, they take the reference PCB design, they tweak a few things, and then they ship it just like that. I guess noteworthy would be like MSI has has protection fuses, Sapphire has protection fuses. Then PowerColor doesn't. PowerColor doesn't. XFX also doesn't. Yeah, so you've got like MSI and Sapphire have the fuses. Asus has arguably the nicest output filtering, and then everything else is basically, well, PowerColor has the most powerful PCB, but that's completely useless because like you're never gonna like, what are you gonna do? Like, okay, so the PCB can handle what's 10 compared like 50% more power, almost something like that, right? Because you've got yeah, so like, okay, so the PCB could probably handle about 40% more current than the, like, basically every other card. And the thing is, like, we're not going to do you any good because you're going to hit the limits in the drivers before you max out the PCB on the reference cards. So, yeah, basically with a 6700 XT, buy whichever one is cheapest. There. And that's why I haven't done PCB breakdowns on these before, because it's just like it's very pointless. Like most of them are just reference designs anyway. They can't overclock that much. They don't pull that much power. You know, there's not even anything weird like where the 6900 XTs just don't have any input filtering. Like, with the exception of the Asus card, everybody basically has a capacitor per power stage for the 6700 XT. Which I like. I have no idea what's going on at AMD with like the recent GPU releases. It's like the GPUs are finally competitive, so we had to figure out some way to be worse than Nvidia. Yeah, that's it for the video. I guess thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. It would be much appreciated if you check those links out because they help out immensely with running the channel. And yeah, that's it for the video. So thanks for watching and goodbye.